proud, we are privileged, we are grateful to Shankar Pal sir, who has made it convenient to be here to deliver the AICTE Distinguished Chair Professor lecture. So before I introduce Professor Pal to all of you, I will request Somdata Madam to come and welcome Professor Pal on behalf of Metro with a bouquet of flowers. So welcome sir to Metro. So I will request Shivamai sir to come and welcome him with a Uttorium. Shivamai sir is a very senior professor, all of us know, and welcome from my side. So I request Professor Ranjita Viswas to come and offer a memento on behalf of us. Lecture आगे की So now it's my present duty to introduce Professor Shankar Pal. I have a one-page write-up in font 9 or 10. So that shows the kind of illustrious biodata it is. So Shankar Pal is currently the National Science Chair, Government of India, and the President, Indian Statistical Institute. He is a distinguished scientist and a former director of ISI, a former distinguished professor of Indian National Science Academy, and former chair professor of Indian National Academy of Engineering. He founded Machine Intelligence Unit and the Center for Supercomputing and Research, a national facility in the institute in Calcutta. He received PhD in radio physics and electronics from Calcutta University in 1979 and another PhD in electrical engineering along with DIC from Imperial College, University of London in 1982. He joined his institute ISI in 1975 and CSIM SRS, where he became the full professor in 1987. Distinguished scientist in 1998, the director of the institute from 2005 to 2010, and the president term from 2022 to 2024. He was the first computer scientist and someone outside statistics and mathematics to become the director of ISI since its inception in 1931. He is also the first ex-employee of ISI to hold the honorable chair of president of ISI after its inception in 1931. He worked at the University of California, Berkeley, and the University of Maryland, College Park in 1986 to 87, the NASA Johnson Space Center, Houston, Texas in 1990 to 92, and in 94, and the US Naval Research Laboratory, Washington, D.C. in 2004. Since 1997, he has served as distinguished visitor of AICTE Computer Society USA for the Asia Pacific region and held several visiting positions in Italy, Poland, Hong Kong, and Australian universities. Professor Pal is a fellow of AICTE, the Academy of Science for Developing World, that is TWAS, International Association for Pattern Recognition, International Association of Fuzzy Systems, Asia Pacific Artificial Intelligence Association, and all the 4 national academies for science and engineering in India. He is a member of the European Academy of Science and Arts. He has co-authored 21 books and about 500 research publications in the areas of pattern recognition, machine learning, image processing, data mining, and web intelligence, soft computing, neural nets, genetic algorithms, fuzzy sets, rough sets, cognitive machine, and bioinformatics. He introduced the soft computing concept and research in India. He visited 45 countries as keynote invited speakers or an academic visitor. He has received the 1990 SS Bhatnagar Award, which is the most coveted award for a scientist in India. 2013 Padma Shri, one of the highest civilian awards by the President of India, and many prestigious awards in India and abroad, including the 1999 G.D. Vita Award, 1998 Om Bhasin Award, 1993 Jawaharlal Nehru Fellowship, 2000 International Award for the President from the President of Iran, then FICCI Award, Vikram Sarabhai Research Award, NASA Tech Zip Award, then Neural Network Outstanding Paper Award, NASA Patent Application Award, Wadhawa Gold Medal, INSA SH Rahil Medal, Indian Science Congress is the Maulana Bart Centenary Gold Medal from Prime Minister of India for lifetime achievement, JC Bose Fellowships, Government of India, and so on and so forth. It goes to the other page also. So is one thing is very loud and clear that he is internationally very well known, and nationally he is a star in the science and technology horizon of our country. So with this brief introduction, I will not take any more time. I request Professor Paul to deliver his lecture on AI and pattern recognition. And if I have missed anything, sir, you can add in your lecture. Thank you very much. Now good afternoon. Actually, I joined my institute on March 1970. So, 28th of February, I completed 48 years. So it's not it is a long 4 years to celebrate Golden Jubilee associated with ISI. As you said, ISI is the Almighty. I was from then I said goodbye electronics. That time I did my pattern recognition. Pattern recognition, no book, done. In ISI didn't subscribe any electrical science class. All was chemistry class. So I had to collect 2 books. One paper or for the last journal, Information and Control Journal. ISI library here. Radio Bridge library was very good. I collected that and in 1972, last Jada's paper in 1970, that paper only collected. That was, I think, after 3 months, I joined the Indian Statistical Institute. And book, only one edited volume, AICTE. AICTE was the father of pattern recognition that time. It is from Purdue University. I'm telling the story because you know may not know. And he has passed away very early age, plus 52, 50. He had an edited volume that was available in my life. And in library one I have GS Silverstein's DSC thesis, which was published by Macmillan. Hard to go through. Very highly research. If you read that thesis, the pattern is become a very difficult subject. So with that background, we started pattern recognition. And today's lecture also, that's why I got pattern. Everything I see, pattern. When I got an MS course at Imperial College, I had a postdoc offer from Purdue, but I didn't go. I went for another PhD because under PhD I can do more work, but I'm going for MS course. So my director, I always took the advice of my director, not my guy. In the evening I used to go to him, sir, what will you do? Statistical, he said, you go there. Another one, you go there. You do this. That's all. Now pattern recognition I will start. And I will see today AI data science is becoming buzzword.
Buzzword means excessive talking. That is a good thing. It is also a bad thing. So at the end of my lecture, I will mention some stuff that I've been telling for the last 3 to 5 years. So okay, now I will start from, because it's a chicken and egg problem, pattern of AI pattern. So I'll start from soft copy. By the way, in the airport incidents that you know, Professor, that was he was going to foreign trip. He took the leave for the health. So I was going to foreign. So international travel in terms of allowance is very small. Our domestic was bigger. So everybody knows one. I will not be together. So let buy it. So I'm for the because foreign leave, you have to take permission of the direct. How because after you give it action, then what I don't know how it will get that one. It's right. Senior professor. I will explain what is soft copy. In my talk, I will explain all examples. No mathematics, nothing. If you have any question, please indicate. Because you say hugely interdisciplinary subject, and it covers my more or less 48 years, but only a part of the 48 subject, which is the actual kind. I'll explain what is soft computing, then pattern recognition and machine intelligence, and then that is subject viewpoint and the machine intelligence, which was established in 1993. So now everybody said that you had a great dictionary. You established only 30 years back, and now we are talking about AI. Then data mining from patterns point of view. Data mining has 3 components: statistical component, the BMS, and we define from patterns. And my former PhD student, we wrote an excellent book given there that time. Data mining from patterns point. Then Fuzzy said that my old subject, relevance of fuzzy logic to pattern, why pattern recognition needs soft computing, Fuzzy said. Then AN, without AN now with deep learning is informed. I have to explain little bit in theory as compared to others. Because many people got deep learning, but they do not know artificial neural network. You have to know deep learning, you have to know shallow learning. If you know shallow learning, you have to know neural network. If you have to neural networks, you have to know pattern recognition. Without knowing, if you jump, then subject will be killed and your career also will be. Okay? So I will explain GN, I will just mention it short. Then I will explain upset lunch time because this is a very new tool emerged from Poland, and it has given us application to data mining and knowledge discovery, and particularly when the data features are uncorrelated. And because when you go to medical hospital, what do you think? Your name, your pathological data, numerical, then family, yes, no, tick, tack. If you go to a medical practitioner, what do you do? He or she writes prescription, numeral, text, color, spelling error, tick, tack. Yes, no. So this is heterogeneous. So they are the classical convention, you cannot use. That's why upset will become so popular. And granular computing, that is one of my hot areas now for the last 10, 12 years. I will explain because to handle large data sets, you need to have computational gain. Then some of the judicial implications for machine uncertainty handling and for computational speed. Then generalized upset for handling uncertainty, how to integrate the uncertainty qualities of handling uncertainty from cognitive process with uncertainty handling capability of upset theory when I uncertainty arising from granular, not the probability. Then up to I think today if I can complete up to this time, then tomorrow I will go application of one application. There are so many applications in big data. only video analytics, I will go. And the last part I will explain, when you do research, where are you going to? At least for this 5 to 7 years, you have to think ahead. What would be utilized? So there I will go for computer theory perception, G-number perception, machine mind development, and then last granular deep learning. Because today this is a very hot topic. So deep learning is very expensive because you need to have lots of data in order to improve the performance. And it is difficult to engineer also. When you increase the number of convolution, for example, in specific image. So we have introduced the concept of granular deep learning to reduce the cost, right? Basically, at the cost of some accuracy. Or sometimes detection accuracy also improves because you are deleting unnecessary. The evaluation of the subject from pattern should be the model subject. Then certain concerns and cautions for the beginning. So that when you start working, you have to keep those things in mind because otherwise, 1980s when we started email, neural network, that was again a buzzword. And buzzword is being delivered by United States every 10 years. And we all Indians and Chinese, we follow. We do postdoc, we go by this. That is basically dictated by them. They are dictating the science of the world. So I will mention those things, certain concerns and now, what is subcomputing? It is explained by Azad. It's a simple example. When you drive, if you know driving, you know parallel parking between two cars in a metro city. In America, this is the first place we have to qualify. I failed 2 times in Houston. I learned driving. It was mandatory. So you have to keep your car exactly between the 2 cars. Now, if you know driving, it's a few seconds. Why? Because you are not asked to solve this problem precisely. If I ask you to solve the problem precisely, for example, you have to keep 6 inches from the footpath of car exactly between 2, then it will take hours to make. So the next person comes, do we need this kind of precision? Answer is no. Most of our data mining problem, we do not have this. It's very expensive. Ultimately, it's meaningless. So that based on this concept, what is objective? Exploit the tolerance for imprecision, uncertainty, approximation, and partiality to achieve this 4 characteristics. Tractability, that is to make the system tractable, robustness, low solution cost, and low risk. Mathematically, to find an approximate solution to the implicity or cognitive. So this is the parking car hydration test. Therefore, this can be considered as a collection of methodologies which do not fight with each other, but they help each other. That means they work synergistically to exploit the tolerance for implicit driving. When you drive a car, you always take this implicit uncertainty approach. It provides the foundation of concept and machine design of machine. I'm just keeping. So, what are the roles of subcomputing? That time, fuzzy logic is algorithm for imprecision and algorithm for handling uncertainty arising from overlapping concept, overlapping region, overlapping boundary, and rigidity. Now, neural computation, machine learning for carpeting and learning. Adaptation. Generally, algorithm was subset optimization. Subset theory we introduced later on that also gives an algorithm for uncertainty and it is not generate. I will explain tomorrow. After I have today at the end, what is basically granular. When you take an image, there is a continuous. When you discretize x-axis, y-axis, and intensity, you make it granular. When information is lost. Now, if you define an object like this, over this, what kind of uncertainty will be average? That's the basic. So within subcomputing, they are all complementary rather than complementary. That is, but every logic has some limitation. Hello, hello. Could you please, because it is a distracting. If you have anything, you just please find that. So this is distracting. Yeah, please, we are looking. So because every tool has some limitation. No tool is foolproof. So you need to have hybridization. That is the challenge. How to hybridize and you get specific application specific merit. That is the merit which you could not achieve using individual numbers. Physiology has limitation on how to define memory. Neural network has limitation on how to define the number of nodes in layer. Genetic has to be a limitation on how to define the mutation probability, crossover probability. These are all heuristics. Accordingly, we defined in 1993 in ISI, basic intelligence, the core concept of grouping the advanced tools, mainly reasoning, uncertainty modeling, data-driven system, the basic concept of data channel. And this list is not exhaustive. As time goes on, you will add those. And basically, it's a core concept of grouping various advanced technology, the basic concept of capture and learn. And any intelligent autonomous system is nothing but physical embodiment of. Now, see that reasoning is very important. Probabilistic reasoning, approximate reasoning, these are all new terms. Probabilistic reasoning, everybody knows. Now, what is pattern? Because you have to know what the machine intelligence, you have to know pattern, basic concept. Now I am explaining pattern recognition. Pattern is whatever you see visually or whatever you listening or not. I am seeing all the human beings about that. When you read a newspaper, character recognition. When you talk about the phone, speaker identification, then speech recognition. So every day, whatever you are doing basically pattern recognition. You walk, obstacle, you move, you go, you're waiting for a bus to open. So basically, it has 3 points. Take an object, you measure it using some sensor. Measurement could be numerical, measurement could be non-numerical. Then out of those measurements, you discard some of the irrelevant parts. It's called feature selection, very important. Today, for data mining problems, it's a very important one. Because all the issues, all the features may not be equally important. And the objective is to you discard those features such that separation between classes increases and separation within a class, homogeneity within a class increases and heterogeneity in the class increases. Very, very simple concept. Then you make a decision. Now, in this system, uncertainty arises from deficiency information. Deficiency comes from incompleteness, impreciseness, ill-definedness, quantitative information, vague information, noise, so on. And uncertainty you cannot remove, but you can reduce, you can control, you can manage. That's why uncertainty handling has become a research issue for many people. And when you have an image, then I put all kinds of processing in image detail. So that image processing in the literature takes about a decade after. You just go for Google, because it was expensive. So as a result, capitalism, image processing by its own right became a different topic altogether. Because of this, because before you recognize what is the content of the image, you need to process the image, enhancement, edge detection, segmentation, cleaning, and so on. So in pattern block diagram, image processing means low-level vision, mid-level vision, high-level vision with an amount of command. Now, there are 2 task items, some important. It's called classification. Suppose I want to partition Bengali versus Punjabi community. I go to Bengal, I collect 1,000 samples. I go to Punjab, I collect 1,000 samples. I the height, weight, complexion, I whatever without weight. Then I see that out of all those, if I take only height and weight, then I can see that most of the Bengalis have less height, less weight. There would be some exception. Punjab is one. So I do not take all those measurements. I reduce it to 1. And by reducing it, you are reducing completion time also. Not only you are increasing the separability, you are also reducing that time. So now I put a straight line, it's y cut ls plus c. This is my boundary. So I store N and C. Now I go to Punjab and Bengal. any other state, Mia or Abul. I collect any percent, I compute the weight, and I see whether it falls on the upper side or no. It is on the upper side, Punjabi, if it is on the straight line, I call it indeterminate. So I make the decision by passing it. Now you see that it is very simple problem. So the next task will be what? So I call it a classifier design. And it's called training set. Now I go to Punjab unknown, I call it districts. So training set should be less, testing set should be more. Now here the challenge is you are given a sample information. 10,000, 10,000 out of the state, but your task is to identify the remaining sample. So that is the challenge. Now in real life problem, life is not so simple. Here see the two classes, similar shape and size, so you get linear boundary. Similar shape but different sizes. For example, one is Tripura and one is Bengal. Then you cannot have state because you have to give more space for the unknown samples from Punjab or Bengal to form. If you go by this kind of classification, you come here. You have these two classes problem, you have piecewise linear bound. Difficult. So overlapping classes, circular. So from linear to non-linear, that means you pay less, you pay high, depending on your need. This is what is called classification. You have some supervised information, labeled information. Your challenge is to identify the unknown one. But you know which class you are coming from. You know how many classes are. Now there is another challenging issue, which is most important. Say national demonstration agency Hazard. They are collecting data of Mother Earth almost 24 years. We do not know which part of Mother Earth satellite is sitting there. So their entire data is given to you. But I do not mention you which part of motherland is come, whether it has water body, precipitation, or what. I do not know how many classes are. So all my task is how to partition into meaningful homogeneous pocket. The term meaningful is subjective. Therefore, you have different solutions. This is what is called cluster. Say, for example, in the family, you have father, mother, son, 4 members. Now, I ask you to partition them into meaningful homogeneous pocket. You can do it age-wise, father, mother, one group, son, daughter. If you go by sex-wise, mother, daughter, if you go by blood chromosome-wise, group, so you see, with these 4 members, you have different solutions. This is called cluster. Therefore, the challenge in clustering is you are given entire data, but no class information, nothing. Your task is to find the meaningful homogeneous pocket if pockets exist. This is called upper one called supervised learning, where you are extracting information out of 10,000 samples for Bengal and Punjab. It's called abstraction. Then you use it for the remaining number of samples for Bengal and Punjab. It's called general learning. So abstraction has to be good. General also has to be good. Neural network abstraction is very good. General but whereas here it's called unsupervised learning. So the term learning was existing back in 1967. Term learning is not new. Supervised and unsupervised. And today clustering is a must for any scientist, applied scientist dealing with data. When we started working, that was subject for elective. Then computer science came. Then statistics and mathematics have jumped to enrich the field. Then became subject of computer science. But today, no. Any data, because when you get a large data, you do not have any idea. What do you do? You say, okay, let us consider there are 2 classes. So you consider 2 and you see the partition with the homogeneous. Okay, let's consider 3, 4, 5. Then when you see the picture, yes, there are some meaningful pockets. From there you can start, at least you know the data has so many pockets. Then you can compute mean, covariance, relation, and so on. So today, clustering is a subject, must subject for anybody dealing with training set, test set. I'll explain. Now, in case of image classification, I will say supervised. Image segmentation, we'll call it unsupervised. Most of the visual problem are unsupervised. Now, pattern recognition and machine learning principle, when they apply to very large data, in terms of size and dimension, I call it heterogeneous data mine. That is for the heterogeneous data. For example, in a newspaper, where you get text, numerical, color, text, so it is called heterogeneous. www where it came, genome project came, string data, link data. So data mining has no meaning unless you have knowledge interpretation in terms of natural language. It's called knowledge discovery. So it is basically a process of identifying valid, novel, potentially useful, and ultimately understandable patterns. Now, this is the evolution I just give to us because tomorrow also last. So pattern came from 1960s, image processing 1970s, AI ML system 1980s, knowledge base 1990, data mining 2000, big data 2010 and today. So you see that around a decade after decade, all those technologies becoming market. Now, before I explain the software tools, let us explain how it originated. Because AI system, how was it coined? Pattern came in 60s. We started working in 70s. And when we started working, that is KIFR and Industrial Science. Nobody else. And I said, three groups, because in India, all science leadership get work in three institutes. If you just go over finance. So expert system became a buzzword in 1980 when I was visiting Berkeley for Salafizade. For expert system, because why? Because pattern has a limitation. It measurements, then make a decision. But that's not the how human mind takes decision. When you go to a medical doctor, what does she say? You tell your symptoms in terms of linguistic term or measurement, pathology. She makes a decision because he has some knowledge. If these are the things, the decision. If these are things, that is, if rule-based system. A rule-based system is much more accessible than drawing graphs and saying that this is the boundary. So, expert system became a buzzword because of the limitation of pattern recognition. Incorporated expert's opinion. That is, expert's opinion in the rule-based, if they rule. And when if they do, it could be probabilistic. That you want the probability that this antecedent will make this kind of consequence. Then fuzzy logic came into picture because everything cannot be quantified in terms of so probability. I will explain. There is a concept of implicit concept also. The Lapset theory came from Poland. I was visiting NASA where I picked up this subject. But Lapset outside in Mali. So accordingly, new terms like rule learning, rule adaptation, point. Before that, no terms were not brought. And then it gave the birth of artificial intelligence and machine learning. In 80s, machine learning means learning the pattern from a data without human intervention. Just one line. Learning the patterns of data from previous experience. Previous experience means video data. And what is happening in this? Basically, computer programming putting in the machine, so the machine can think like human. This is just in layman's sense. So AI and machine learning came based on the realization of Alan Turing in 1947. What did 1987 Alan Turing passed away very early age of 40 plus for Kelly? He said we need a machine that can learn from environment, and that's what his comment in 1947 his lecture at London Mathematical Society. You look at my paper, famous paper, you will go there. So he already mentioned that back in 1947, that is a vision of machine, intelligent machine. That is machine that can think and act like human. And then neural network reappeared in 80s. Those who are senior in my age, they will be knowing. In 80s, again neural network reappeared. But neural network is a good candidate for machine learning. I will explain. So it was become a very hot topic Too many journals, too many publications, too many funding are coming from Europe. In my institute, we started the AI course, but after 2 to 3 years, we could not survive because we did not have adequate computer processing power, we did not have available data. So no job. My institute in 84, 85, we run. So 4-year courses. Initially, we opted for it, but afterward, nobody's come. That way, subject did not survive because we don't have the processing power. We don't have the memory chip. We don't have the available data. Today, we have got abundant data. So deep learning and machine learning became a very good choice, and it is again revived. So accordingly, after 5 years, we have advanced form of expert system called knowledge-based system. And even if we have 5 knowledge-based systems, ISI, TIFR, IIT Kanpur, IIT Madras, and CEDAT. So what also is the advanced computing? You use higher level knowledge like semantic, magnetic in the rule and the information system, which was available in the earlier expert system. And you use the domain knowledge to design new knowledge of the existing. That's a medical doctor. They have such a score base. When a new sample comes, new case, what do you do? If it does not match exactly, they make it adapt. Okay, so that's how you say advanced knowledge expert system. And every time we get new knowledge, so case-based reasoning became a hot topic. Just like medical doctors, law interpreters, it's called they take case-based reasoning. That is, I do not generalize your case. I also say that your case, I'm going to see whether it is similar to other cases. It's called case-based reasoning. That is, I go by case, individual merit or debate. Then I have got in-person retrieval, rule learning, and all those new terms find. And emergence of soft computing. Because it provides flexibility, adaptability, low-cost solution, and implementation, as I mentioned before. So it originated around in 90s. Out of this need. And what is the intelligent system characteristic? Better system should have uncertainty handling capability. It should have reasoning capability, adaptivity and learning capability. That is women, a girl when it is married and go to the RL. What is it? She or she gets nicely adapted. So he will have that capability, adaptivity capability. Searching also, I'm going to ask you about the common. Then competition speed. This is called machine learning. Now I will explain the relevance of some computing in pattern learning. The pattern learning is my mother subject. And these are all these characteristics which subcomputing takes care of. That's why I told first subcomputing, then I will approach it to us. And subcomputing provides the backbone of modern artificial intelligence. Now, relevance of subcomputing in progress. One of the challenging conditions is overlapping. That kills us already. Classes are overlapping. Classes are skewed distribution. Classes are incomplete. What do you do? Probability theory is famous. There is no doubt of it. But it has limitation when your data does not follow any distribution. When the data are scarce, what you get? Small numbers. So Bayesian theory came into the picture that we started working with one. So probability distribution function dictates probability theory. Membership function dictates Bayesian. Bayesian theory is explained by Lafayette. Famous paper which has 1,23,700 citation. Abul. I think now it has gone out. If possible, you will read this. And that paper was stolen from my library. I don't know who has taken the blame. So Lafayette, he first explained. He passed away on September 6, 2007 at the age of 96. I had the opportunity to invite him and just confer him on a rainy days. He didn't want to come. I have to just give him some carrot. You please come, we will just give you this honor from ISAC. So what is Bayesian theory? Should I explain it to slides? Huh? You know classical set theory. What is classical set theory? Set of boys If you have a boy, no, doesn't happen. Set of integers between 9 to 12, there will be any integer below 9 or after 12, they are not there. So 0 or 1. Yes or no. Examination pass or fail. But in real life problem, we encounter maximum number of concepts we do not have well defined bound. Say, Maulana, beautiful lady, long street, blonde hair. It's just a slowly drying. So there is no clear cut bound. That means any lady is beautiful, it's a matter of degree. Any number is large, it's a matter of degree. Just need to think of there is no piece boundary. Therefore, the characterization set would be initially it was 0, 1, no, yes, black and white. Now it is soft. That is anybody from 0 to 1, I call it a fuzzy set. That is any element belongs to the set with a pattern of degree between 0 and 1. Other than 1 is extremely either 0 or 1, it becomes. So mathematicians jump and then get classical set. Mathematicians are very clever, very clever. We do not seek for our patterns because when classes are overlapping, that's the first concept that came into mind. We should not make 0, 1 is possibility. Similarly, in the image, since it's a gray image, I cannot say this pattern goes to this class because this is a gray. So there is a concept, it should be fuzzy. Therefore, tall men, these are the typical curve, and it is written as membership function associated with X. Not in a classical set, is only actions of X because it belongs on both of them, but it's a membership function. And membership functions are, it denotes the degree of belonging of an element X with the imprecise concept A, or degree of compatibility. The degree of compatibility of an element with an imprecise concept as represented by the set. This is already long street. Beautiful lady. These are all imprecise concepts. Similarly, in the class, overlapping class, I can call it an imprecise concept. So any pattern can belong to a one. And so fuzzy sets are nothing but membership. Classical sets are set of values. They are membership. Membership functions are context dependent. What is context dependent? Suppose I ask you to meet your friend at 5 o'clock at some point. So what do you think? So 5 minutes, it could be 5 to 5, 5 past 5, 10 to 5, 10 past 5, depending on the context. So in real life problem, it is nowhere. Ideally, it was 5 o'clock, this at 5, characteristic value 1. This is a fixed set. But in practice, it becomes a fuzzy set. Now, if you go to China, or even Japan, their concept 5 o'clock is 5 o'clock, very precise. But in my country, from the middle of the concept of Kharagpur, if you want to catch station, 10 comes of 5, you know, sometimes it becomes much later. Understand? So this is called physical. Now, same thing, context dependent. Suppose at your young stage, when you have girlfriend boyfriend, when you go, you say you are asked to meet at 5 o'clock some point, you always try to go before 5. So that you can spend more time with your partner, right? Right? So their time starts from much before, no way after 5. But when the relation gets older, many times, you go after 5 to make our party unhappy, angry, right? So say 5 o'clock between 2 persons, it is a context. So tall man in India, tall man in Canary, logic-based system for character recognition cannot be used for a distribution system for set character recognition in China. It's a context. I hope it is clear. Now, what is the difference? So fuzzy sets are nothing but membership function. Fuzzy sets are context dependent. Fuzzy sets are elastic. That means you can play with the membership value depending on the situation. But hard set, no, yes, no. So it has better flexibility capability. Better capability of uncertainty modeling class. Concept was okay. Now you can ask, sir, what's the difference between probability? No. Probability is concerned with the number of times an element has occurred. But if the fuzzy set members is no, there is no element. There is no concept of number of friends. It's a concept of competitive of an objective intelligence. There are so many examples I give. So you keep these two things in mind. Yeah? So flexibility, uncertain knowledge, overlapping data, that's why ideology became popular. Now, beginning out the when we started working was the challenge how to abstract concept of fuzzy set and pattern recognition. So that's how we brought this relation between fuzzy set and pattern image processing. That was our first paper from my side. I did a transaction of system and stability where was a lovely jacket 70 paper. That is the paper on image processing from UPL college. We did a transaction. So that was the earliest paper, basically, image processing. Compared to pattern recognition, that's why you see that those papers are getting highly cited. Then the notion of multi-class belonging as I mentioned. Then similarly, the gray image is a sinusoidal image. So we have the boundary. If I ask you where is the boundary, because it is gray. So it defines a fuzzy boundary, fuzzy edges, fuzzy relation, or non-relation relations. So it's a multi-class membership of pixel. That is, any pixel belongs to a class with a matter of 0 to 1, not 0 or 1. That's the basic contribution of assembly pattern back in 70s. And it has got linguistic phrasing, low, medium, high, multi-class, generative rules, image processing, etc. Now, it has a multi-class belonging that is a three-class problem. Any pattern can be represented as a three-dimensional. Now, the next question comes on what will you do the three-dimensional? Yes, you can make first choice, second choice, or for example, in how are these? There are so many examples. So this is our remote sensing data. If you look at the bridge in the infrared, there are how many classes? Water, this pure water, concrete, habitation, vegetation, open space, 6 class form. The river Hooghly, Howrah. Okay, these are the 6 classes. Now see that all the these pictures are not identified as concrete because it's a 20 meter by 20 meter resolution. So that reflects some from road, some from the concrete, some from the water. Now I see an example, the concrete body. If I say the first choice, that the first choice says concrete, this color, combined choice gives this. That is, this and this to be both. Then second choice gives this. So if I have this fuzzy information about this bridge, if I do not discuss it by making 0 or 1, then with the level of a higher level information, that a bridge must be connected in that side with road. That high level information is that. So if our roads are pixels are correctly identified with the road, then I can link them as this. So that's how it helps. If I would not have made this fuzzy, if I have said yes or no, then I lost the. Because once you make great information, that is expressed. There are so many examples. Now I'm coming for learning and adaptation capability also. So artificial neural network. Now many of you might be knowing that our brain has 10 to the 11 to 10 to the 13 as per the literature, some biological units, which is kept like that. It's a cell soma, which is the processing power. Receives information through synapse, then transform the output through our dendrites, it goes to again our cell, soma. So basically it is a interconnected components of different cells. So we electrical engineers, we consider it because this human intelligence and distributed power is basically attributed to massively connected or biological. So we define artificial neural network or computer neural network that is a very simple processing. That means you can do additional subtraction, not your quadratic equation. It's a simple processing. Yes, operating in parallel, this function is taken by 3 parameters. That is, functions computation done in the processing. How are they connected? That is the topology of the neurons and the weighting coefficient between them. that is network structure, topology, connection strength, and processing. These three things determine whether it is a neuron of elephant or human. This is the biological we are taking it native. Now let us model it. How can you do this? Have you worked in neural network, anybody? Anybody? Yeah. Okay, so now I'm explaining in a slide. Let me emulate this one. So I have a processor. It takes input A1, waiting factor W1, A2, A2. This is my input. It does some processing and sends out. So what kind of processing? So my summation is weighted sum. Weighted sum. I give a transformation function F. It is suppose it's a two-step. Two-step. That means if it crosses the threshold 0, I call neuron as fired 1. If it don't, it's a no. That means every neuron is responsible for generating 2 regions. Yes or no? And in general, decision boundary will be linear. So my equation is now A1, B1, B2 plus equal to 0. If it greater than 0, plus 2, less than 0, plus 1. So this is a linear equation. Right? So one neuron is capable of generating one figure, separating 2 classes. And bias is provides the adjustment. That is y equal to mx plus c. C is controlled by the bias. You can shift it to one. If bias is 0, then the C equals to 0, you get this. So how do you make the training? To set a, suppose this is a two-class problem, memory and Punjab. So you are giving 1,000 samples for Bengal and Punjab. When you say that 1,000 samples go to Bengal, you want that Bengali node should be 1, Punjabi node should be 0. That is your desire. And when you are giving the Punjabi samples, you expect Bengali node output to be 0 and will be 1. This is your desire. But you do not get the desired one. Initially, because you are given the random solution, you get something else different. So you compute the error between desire and the obtained error. And you multiply with the activation value. So larger the number because which has generated this. Then you will correct the AICTE coefficient depending on the input AI. So delta multiplied. So larger the input activation value, larger will be the corrective factor, and eta is the learning rate. That's how you write for the loading. So this is the called delta learning. Clear? So I want to make delta equal to 0 or some value, that is up to you. To what extent you make it neuron learn. Now you see that single neuron is responsible for 2-class problem for separate ones. Because one neuron is generated one. If you have more than 2 regions or they are non-linear. So for this class of problem, you need 1, 2, at least 3 neurons. They have to be ordered in such a way, it's called multilayer perception. Here, perception doesn't. Similar for here, unit 3, it's like multilayer perception. Because you need three neurons, how would you organize? In 1 layer or 2 layers? It's called multilayer. Similar for here, multilayer or multilayer. So, what is the characteristic? It learns from examples. Okay, I do not need to know the input output mathematics. Just give me something. If this is the one, this is one. If this is the one, this is the one. If this is the one, then one. This is the one. You give the 1,000 samples, I learn it. This is called black box character. That is the criticism. That how do you know? You do not believe it. Enforce the relation between input and output further complicated. And it's a good candidate for machine learning. Good candidate for machine learning. And it has adaptability to news, data and environment as human being, robustness, largest test to computer. If you cut down one node, it works. Just like human being, you get hard. You do not try something. It's a gracefully degradation. So here also, if you cut one node only, it will not collapse. It will degrade because it is a redundant system. Speed biomass parallelism, optimality. So all these features, any design engineer would love to have these are our system. So machinery for learning and computing, construction and development will be ready, followed by testing. And in case of pattern recognition problem, say resistance to noise, tolerance to distorted pattern, the ability to generalization more, superior ability to classify highly nonlinear boundary or partial occupied, potential for parallel processing and this non-parallel. So you do not need to know the distribution of the samples. Similar genetic calculation is a structure optimization. Why we need is I'm just keeping biologically inspired technology. This provides adaptive search method which is parallel and robust, providing near optimal solution potential, suitable for search space when the search space is large. And in case of pattern and image policy, your performance depends on the number of parameters. And you can, that is one of the bottlenecks. What you achieve for edge detection or segmentation is not applicable to all kinds of cases. So there, this parameter tuning I can make with JDI. So it is a method developed for pattern and image policy usually are problem dependent. Many tasks involved to need attribute parameter selection and efficiency. So it is computationally intensive, possibility of losing the exact solution. Now I'm going to graph set. It's very important, just you listen. Granular concept, I will explain granular. For the beginning, I will tell you one example. Suppose I'm seeing that one. I see some old people here, some young people here, some young people here, some lady here. Without knowing the one, these are my older people granule, young lady granule, young boy granule. When I see scene, what I see is sky, water body, greeneries, house. So this is my plan. I do not have to look at the individual picture. In a school, suppose every section has got different number of students. So every section is determined either by age group or by marks of in the previous class or sex. So I can every section school can be considered as a granulated section. There are many such examples. In an image, since it is a discretized, we have introduced already granular, losing information. Now, you can define region of similar color as granular. Even one pixel can be also considered as a granular because you have identity. So, granulated concept is now within the granulated concept. I define a set. So, this is my set. For example, a granulated system, x-axis, y-axis. And these are all my granules. That is here. All elements cannot be segregated in terms of the relation, say sex, age, or whatever in the school. And if I add one more dimension, the granule size will be reduced. So uncertainty is coming because of the granule. Because you have partitioned the school into different sections. Now I define a crisp set for this one. And I ask you that what are the granules which will belong to this? Now see that there are two possible solutions. One is the granules here by the year one, they all definitely belong to this set. I call it lower optimal solution. That is, all these sections. I will give the example. Now another one is orange, where you see that some of the granules are on the boundary. This granule, boundary. So this is I call upper approximation. That means these granules, they definitely belong to this set, green set, and red that contains the granule, which is also a subset of the superset of this. And they have the granules which definitely as well as possibly belong. So yellow granules means they definitely belong, and red granules means definitely as well as possibly, because lower is a subset of upper. So it's called upper minus lower. These are my boundary granules. Then it causes uncertainty. And if there is no granularity, there is no answer. Now look at it in school. Some contaminated disease has been spread. Now the principal has made a decision on the infected classes should be declared holiday or not. So how to define infected classes? When all the students in a section are infected, definitely they have to be declared. They have to warn. But there are some sections where not all the students, but at least one student was infected. So they constitute called performance. So having this defined defined roughness of this set in terms of granularity, 1 minus cardinality lower line. So if cardinality lower equal to upper, then 1 minus 1 0. That is, if there is no granularity, there is no roughness. Very interesting concept. Therefore, I can say the rough set, even though the name is rough, but basically it's a crisp set. If I over it with rough description in terms of knowledge. That's why I said I can give you 1,000 examples. Long C, larger number, but here I cannot because this set is clear. Then I will explain how to make it same set again. So rough set is the definition of concept problem. And this vague definition of X in terms of lower and upper that signifies the incomplete knowledge about you. The vagueness is coming because of the granularity. So when I use a rough set to decision, my objective would be to minimize the incompleteness to make a decision. Now I said the rough set theory has two aspects. I picked up the subject when I was working in NASA, and that time these students they are very good in maths. They used to come, I don't know, many people may or may not know, in NASA not only does research in space, they also fund research to university students for PhD program, internship program, 2 months, 3 months. So whenever they used to come, they used to give a delivery talk. I used to attend those talks back in 1992. So I see that I have detailed expertise about image processing and transaction that time. And also expert system have just appeared, neural network just appearing. The uncertainty handling I can make using lower because I have the knowledge in data promotion that uncertainty coming from overlapping here also I can uncertainty. And I have to consider granule, not the terminology, but I can use the concept of granule, which gives a compressed information. Compressed information. For example, here I see some old people, some young lady, some young by 3 granules. So I forget everything. I based on extract information out of the 3. So since I gained compressed information, I will gain in terms of compression. So we have certificates for handling large data. That was my objective that time when we started this point. So in machine learning concept, what you say? Suppose this is a granulated domain, this is a cluster. Again, abstraction means a cluster. Machine learning means subcluster concept. Now, every cluster, you know, some patterns or their belonging we have no doubt. For example, this pattern, we have no doubt. When they are close to the centroid, for their belonging, we have no doubt. Our doubt comes only from the number inside. So I can, in the rough synthetic notation, I can also call this is my lower approximation, this is my upper minus lower. That's how in machine learning concept we brought it. Therefore, roughness of this beta is cluster will be 1 minus. Fine. There is a body line. Now I say that in real problem, cluster, the set and the granules, both or either could be fuzzy. In case of Kalam, he considered both are crisp. Set is crisp, granule is crisp in his definition. But when, for example, in the image, since the boundary is fuzzy, so if I say that set, how can I say this object? So their set is fuzzy. It could be fuzzy. Similarly, if you are wanting image processing, you move over 3 by 3 beta window. So 3 by 3 window, if I consider the value, so in real life problem, without considering them both crisp, one of them could be, or both of them could be That means we will go for higher level of uncertainty. So then I will classify. Then what will happen? Fuzzy sets are nothing but membership function. So my lower set will be membership function, upper set will be membership. So lower approximation will be set, which is fuzzy set, characterized by lower approximation. Now I have cardinality in terms of number of cards. That time I have to compute the membership function, all the membership values adding them. It's called cardinality of the fuzzy set. So in sets and gamut of either a fuzzy, lower approximation will be the fuzzy membership function, and this gives rise to generalized subsets. So the concept was that one of our PhD students now is in associate professor in IIT Kalam, electronics and there was generalized subset. I will explain the generalization theory later on. So it's always common model concept. Why? I am incorporating uncertainty arising from homology concept, uncertainty arising from granular, but not probability. Probability is uncertainty arising from randomness of occurrence in a detail. I'm not considering it. If you bring that will be even much more powerful paradigm for handling uncertainty. I am just leaving this for you as a homework. So uncertainty of homology and this. Now, before I define the generalized rough set membership function, I give you explain. So it's called generalized rough fuzzy set. I explained what is information value. Suppose this is a class concept region. Whatever you think. This is my granular. This is a projection. Now, given this set, given this region, given this class, whether it is labeled or unlabeled, whether you know its origin, whether it's Bengal or Punjab, I don't know. It is labeled or unlabeled, subset can encode with the help of this relation. That is, first feature is medium, second feature is, that means it is a rectangle. Approximation. So I forget this and I call it good description of the class. I call it lower approximation. I call it case. I can call it a prototype. I can call it a representative of the class. Now I can see that if I want to know the exact boundary, then I can start from here and pay little money to get the one. Instead of if I start from the beginning, then it will be lots of. But in most of the problem, this approximation will fit. Now, this is a prime example. Suppose the class is elongated. Then you will need multiple such curves. Right? Now you have one granule. Suppose the class is elongated. So one granule to multiply. And interestingly, I will show this relation may not have all these features appear. Therefore, there is a possibility of dimensionality reduction. I will just show an example. So there is a possibility of dimension reduction, and dimension reduction will be variable. That is, for all the classes, same amount of reduction is not required. In our classical machine learning problem, when you are making dimension reduction, is for all classes, dimension has been used. But here it is a variable. So we have less storage requirement. Therefore, fast retrieval, suitable mining, that is with so many advantages. Example, iris flower, you have to know iris flower. What is the flower? Iris flower? 3 types of flower. This is a very simple data. Flower, 50 flowers for each class. 4 features, sepal length, petal length. Very simple class problem. Now we see that what is the character? These are the 3 flowers. Now I like to extract some trace, some representative, which I will give better story in terms of generation retrieval as well as for classification of the remaining parts. So look at the scatter plot. First, you look when the data, if you work at data, you first look at the data. Don't use the tool. First, essentially, just study the data of that person. So if you have a lower dimensional data, you just scatter from one dimensional, two dimensional, put together. So three features, I can put 3 C2, so 6 dimension. If you look at this, two colors are overlapping, other are not. See, that means in order to segregate these two overlapping classes, I may need all the 4 features as much as possible. But for this class, only 1 feature is enough. So I do not need 4 features. That's our intuition here. That's why I do not need equal number of dimensional injection for all the features. That's what will happen when you compare it with they did our instance-based learning, very popular, very scientific. Then this modified learning, where we have the dimensional reduction. We take the parameter average number of features required to store a case. Case is 1 power. So I consider 3 cases. So from randomly I take up from 3 to 1 power. That is generation time is almost 0. And another way is the upset approach, I have some cases as I do. And I compare in terms of average number of features required. With these features, generation time, these features, retrieval time, and with this feature, capability of classifying the remaining samples. Say, online KLM classifier is a very popular classifier. So you see that for all the methodologies, they need all 4 features. But for the proposed one, 2.5. That is, also in all 3, we do not need 4 features for them. So since it is 1, retrieval can be 0. But if you do the retrieval smaller size, your classifier accuracy is enough. And here, almost 0 is for the random, that is, you pick up 1 sample from the next one. There are many such examples. So now I'm commenting what is the granular part. Based on this part. I have explained you the granule. I have explained the rough theory. Now granular computing, I'm going back to it. Granular computing is basically natural thrust. That you replace a fine-grained universe by a coarse-grained one, more like a human person. Just like I said, these are all, there is no fuzziness. It's precise. But when I see a set of atoms, set of children, old people, girls, boys, and so on. So it's a process like self-organization, self-production, morphogenesis, Darwin evolution that abstracted from natural phenomenon. And in the process, the clusters and segments that we generate as well. So granulation means process of formation represented from. The first is granulation. That's how our human mind works. That's like self-reproduction, Darwin evolution, self-organization. Similarly, granulation. And the product that we form is granule. Now, granules evolve in the system depending on the task evolve. Now, with the granulated domain, some examples, it will be clump of indissoluble entities drawn together in terms of say similarity, property, proximity, functionality together. For example, if you take a vector space, you go by the closeness. In an image, you go by similar color. You go by the genome data, gene data, there you go by the similarity in terms of function. So with respect to some property, when you make them together, it's called example when an age, very young, when you drive a car, slightly left, slightly right, in a school, each class section can be considered as a granule. In an image, here, there are 6 consecutive levels. 1 to 6, 2 to 7, 3 to 8. But that is I cannot discriminate. So I can consider it as a granule. So look at this. Granules could be crisp. Here it is granule fuzzy. Here it is crisp. So granules could be crisp. And over that, when you define a cell, I characterize it as a. Now, as I mentioned, the granular computing will be there. It's a twofold task. It's a natural information processing paradigm that works with the process of information diagnosis and access. That is how you have extracted this cluster or how you have extracted those relations. You shall call the information granulation. And then you perform the operation, following operation based on those granules. You forget the granule. And since granulation is compressed information, therefore you are gaining computational gain and suitable for finding these data sets. So in summary, it's a naturally inspired information processing paradigm with the basic element of granules. Granules are collection of indistinguishable objects drawn together in terms of some property like similarity, functionality, physical proximity. Granules evolve in the process of abstraction in the informal abstract function and derivation of knowledge. And varying the size and shape of granule, you can determine the different levels of granule, in which level you want to have perfection. You can characterize different aspects of the problem. You represent the model differently, and therefore you regulate the decision-making task accordingly. Therefore, granules play a significant in granular complexity. No tool is foolproof. When you go, you have some other. So concept of granulation, look at this in inherent Five-step membership function, that means it itself granulates the feature space. Rough safety, as I mentioned, it's a defined on the concept of granulation. Granular property term was not defined by Professor Maulana. It's a granule. So rough safety, that's why it became a granulated domain, is defined over this granulated domain. And that's why in the literature, these are the tools which are most successful for granular property. And out of those, rough safety, most. So there are so many applications, case-based reasoning you can do, prototype generation. So once you have prototype generation, you just whatever. In a clustering problem, what is the challenge? You do not know the number of clusters. But here, I can have the number of granules. So number of granules means I can assume initial number of granules, my number of initial classes. Then from the granules, I can copy mean and covariance matrix. Then I can do further processing. So clustering, image segmentation, data compression. You store this relation. You forget that, just as you store it. You just transmit it. Granular information interval in heterogeneity, that is another very good relation theory. Where text, hypertext, image, text. Now I explain all these individual tools. Now the challenge is how to make them integration. Because every tool has some limitation. I will just show two examples. One. First is in late 80s, we started, including myself. We started thinking, why not integrate? That's why Dr. Sushmita went to join as a research scholar. The neural network, it takes input and only numerical value, and output either 0 1. But in neural network, it could be linguistic also, and output it could be fuzzy also. So we thought, why not integration all those? Among those, zero fuzzy hybridization is the most visible. That's why in the market, zero fuzzy camcorder, zero fuzzy television, zero fuzzy refrigerator. What is zero fuzzy basically? That means, I said there are models to mimic human reasoning and capability of uncertainty handling. Neural networks emulate architecture information represented by human. So if this provides the software, this can provide the hardware. But this is too ideal. We could not do this. That was our objective. But it was, then I realized it is too difficult to emulate the architecture information represented by human brain. Because it needs psychology, biology, physics, mathematics. So then we didn't know it's a tool, we go by it. So based on the realization, if you can judiciously making it is called zero fuzzy computing for more intelligent decision making. For example, you buy this neural network, which has capability of generating nonlinear boundary. I explain multi-layer perception. I take input, low, medium, high, output also. And here, during getting decision starts back propagation. In case of classical multi-layer perceptron, I transmit through this process. Here, since a membership value, I transmit the back, I back propagate the error through all the nodes depending on the view. Initially, I used to do only through one node, for which the sample was one. So it handles imprecise input, handling uncertainty arising from one-level classes. Back propagate errors are assigned appropriate weightage depending on new values on techniques and can handle the mistake. So as a result, since I have back propagated the error through all the nodes depending on the weighting value, my boundary slightly slowly shifts for this outcome. This is the beauty of that paper received that 22 ITB outstanding paper award. That time it was ITB Neural Network Council, just originated. Now it is a neural network society, computational intelligence society. So look at this before I go further. Jade defined subcomputing in 1994. But before that, it already this work is 1992. That we started working in 2 years before 1988. Paper was 90, paper award in 92. So we started working in 88. So although Jade formally defined in 94 subcomputing, it is different challenge of synergistic integration between fuzzy logic A and B1 were addressed much before specification since 1990 or before. So many people do not know this. This is a basic challenge of subcomputing. And my Indian Institute of we have this DST Center for Subcomputing, National Constitute of Einstein, given by ACR, by ACR DST. That time, not ACR DST, and there is university, and this is ACR's first center in subcomputing research. Now, one example for rough fuzzy. When I was working with this Professor Abul in Poland back in 1997, then we wrote this edited volume, how to integrate this fuzzy and rough. This is the first book in 1980. It's an edited book. It has 12 papers, granularity, fuzzy set. Now, what to do? The same particular percentage that they are shown, I take it. I have input, low, medium, high. I know this. Now I sit there, since it is a domain knowledge, it is a supervised knowledge, I have the training data of it. So if you have the training data, why don't we expect some domain knowledge using Raman? That I encode every classes in terms of computation, and I put this relation in the initial neural network parameter. So then my neural network starts learning from a data. That is, learning time will be reduced. And gradient descent search is a very slow process. It may get stuck to local minima, where the number of parameters in the subspace increase. So therefore, to elevate this, you can use genetic algorithm based streaming to get parallel sorting on delay pass. So that's one of the examples how these four tools can be synergistically integrated. And you achieve in terms of computation time, you achieve in terms of learning time, you gain in terms of accuracy also. I'll show you one. Another example, modular rough fuzzy. These are all machine learning problems. What is modular? You have a problem now. You have n-class problem. If you started building a neural network from n-class problem, it will take lots of time. So in spite of that, if I say you split n-class problem into n-2-class problem. N-2-class problem. So split n-class problem into n-2-class. Simpler sums. For simpler sums, it is easy to take. Say instead of Bengali, Punjabi, Uriya, this is for only Bengali, this is for only Punjabi, this is for Uriya. So I take only for Bengali or not, take only for Uriya or not, take only for Punjabi or not. Now I integrate it. That's the thing. So some networks are trained and integrated using genetic algorithm with variable mutation operation. What is variable mutation operation? That is when they integrate them, the network which we already defined for Bengali, Punjabi, Uriya, we do not want to change them. But as a result of concatenation, there are some new links needs to be generated. So for them, I give high mutation probability, and those we already developed before will give me low mutation. This is called variable mutation. So what you gain basically is a final solution network has more structured component. Because you know it is a Bengal, it's a India. Now it is a visibility is more. Initially it was a black box. You don't know which part is responsible for Bengali Punjab. Now we have got this. Individual clusters is better preserved in final structure. That's the most important thing. It's called imbalanced cluster. When you have a bigger cluster and a smaller cluster, say Tripura and Western, big cluster, solo, a smaller cluster. You get very good recognition score at the cost of this. Suppose you are identifying this is a normal. Normal sample is 10 and the disease sample is 1000. So when the 10 samples are currently identified as a normal, it doesn't matter to get the overall score. But it was the must not be having. Cancerous should be treated as cancerous, normal should be treated as normal. So that the number of samples is small. So yeah, since I am doing for Odia, Bengali, and Punjabi differently, that means the identities are remaining preserved. The catastrophic interference problem between the one will be reduced, not removed, reduced. For example, this simple one class problem, we train it first, then we integrate it. These are the links we have already developed. So I give this link solid line, I give this low mutation forward. That means we will change it very less probability. But these are the links to be grown, we give it larger probability, mutation probability. And ultimately we develop this, we see that not all the links are equal. It's called structure. So now structure means when you generate the rules will be less ambiguous. Because more rules, more sample is redundant, redundancy is ambiguity is more. So how do you get the knowledge transfer? Initially, you started with this kind of link, for example, low, medium, and each link gives this kind of gradient. And then with the obtaining, these two values get merged. Then finally, so that's how the knowledge flew from initial to final stages. And whatever many you get in the NSS classes performance, training time, network compactness, that is redundancy, redundant network units are no more existing. General rules of higher accuracy, smaller size, less compact. Now I'm coming to generalized large sets. How much time? Okay. Yeah. Because I have still 10 slides. So if I want to copy, I can copy. Tomorrow. Okay. Okay. So that you can take some questions and okay. So please. Please, because now I'm going over the definition of this all kinds of generalization, and then application followed by the application. So if you have any doubt regarding the Kalam competition, it's a very great topic. Topic that we developed from our laboratory more than 8 years. And we have been publishing good number of the good quality papers.
Question is actually introduction starting from the basics to this lab set, especially the combination of all these tools. In fact, that is the thing. But I think okay, one very generalized question after this topic. But you know, one thing, because you are the right person perhaps to give me that answer. See, whatever the people do in the West, we generally follow, as you also said. Now, what is the basic reason and how we can overcome this? Because if you see, especially in our scientific, research, before independence, people were introducing things, but after independence, we have become followers in almost every respect. But what is the basic problem and how we can overcome that? That's not
It's also scientifically and technologically, in India, what we had 40 years back, or the 50 years back, for this one. Now, difference is not. Difference is there. Difference is not. China had though they got independence 2 years after 1947. But the subject wise, it comes from the demand of the society. Because that is generated out of the interaction of the human with the society. So when you are, every technology has some limitation when you see that it has certain state. So what to do next? Then by the time technology improves, you get more information. As a result, since America is a richer country, they have all PC. And our best students of the world, face mine. Most of them they join them. There is no doubt. Even our students in our countries, if they get a better opportunity in America, would say more for learning. So obviously they have the rights to dictate that this is the time. But who writes the paper, that's important. What you are writing is not right, not that's also important. Who writes the thing? Similarly, now the difference is place, but opportunity also. There are opportunity more, but we are, except few pockets in India, except few pockets. There is no scope for very good lab system or one. So there are many things. But within this also, China has one sword. China is only something now. It is now difficult to compete with China. It is easy to compete with China in mind. The difficult one, China is now tsunami. In my eyes, I think that China, like 90 every year, for the last 2 years, I'm not able to vote many petitions. About 90 and 98, I did visiting China every year. I passport put them 1.1 per year. I've seen that go from 99. And now collaboration. I have many Chinese students. I have the candidates to students from China. So I know the difference between Chinese students and Indian. They are not discussed. Indian students get hard. There is a big difference. Patronizing, nationalism, determination, this is basically difference. But even otherwise, now the difference is American. Yes. But the need is there. When we say pattern recognition, we started from there. Our example was the foreign example. Why foreign example? We don't have the experience. Now in many institutes they do not go. Although I prefer at least one PC later let them go. Just like CID instead of CID go for CBI. Why? This is the thing. Our own. Yes, it's okay. So if you have our next university, it may not be that good also. So that's how we started working expert system. That's why I was explaining how the subject evolved. It's not that suddenly one in the morning it just came from science. It's a pattern recognition. Then AI because the need because doctors they do not go by the pattern. This is only with people you talk. When patterns are originated, why? Because to identify the crack in a breed. That's what was a case who told me in Oxford when I was chatting with me when they feel knowledge. Why people are spending so much time after convert this. I do not understand. This is originated from the need of the electrical engineer. How to identify hydrogen character to machine, how to communicate with the machine in own language. Machine understands only its language, that it was Fortran and etc. So now that was our objective. So objective was there. Similarly, big data came in 2010 because of genome project and internet. So all technology patterns you have developed before 80s, they are no way. I will explain. They are no way useful. But they are asking number of samples large, features small. Now the other way. Number of genes are only a few thousand. Number of samples, disease organisms, few K. Even number of normal patients is more than number of cancer patients. So you go to hospital only when you're sick. Normal people actually go to hospital with this class. So the sample ratio has changed. And here the RNA, I don't have time to go into, they are uncorrelated. When we assume our pattern shift theory, they are correlated. That's a physical component is very useful. At that time, we used to partition sample space so that with respect to which feature it gives better severability. We publish paper in AICTE sample. But after AICTE, no. You have to scatter sample, you have to cluster the sample space, feature space. So if you have 1,000 features, they are uncorrelated. So if you automatically tick one group, numerical one group, yes, no, one group, color one group. So out of the they are uncorrelated. Then you centroid pick up. So from 2,000 you come down to 2. So that's how our 1982 I think the public paper paper. So depending on that data, technology is to change, new terms are coming up, methodology. So I agree that after 80 federation web studies, those theories are not applicable because of the data. Now, similarly, the big data. So how can we say machine learning data? Meteorology department, they invited me next week to give a presentation from Maulana lecture on the world meteorology data. So they are also machine learning, not like machine. And they are data, they don't know how we can keep so data. So Caltech University we go, they view 1950 by machine. Oh, yeah. But today you cannot say. We have all visited. So all this information they are asking me, sir, you just explain why we go for machine learning and how to use it. Because they also tell that it is now the generating data, they are generating with the big data. Satellite is generating, radar is generating. See, data is abundant. You cannot lie. Out of that data, you will get some better source. That's the option. Better. So that is really there for AI machine. You cannot handle those kind of. Now you have a powerful sample, processing power, available data. Nobody, or you have. If I say no, I will not go.
So you have more than 300 participants online. Any question, Anjan, from them? Or some questions?
Oh, okay. But we are also using our own model. So prediction is also prediction is also and you are predicting based on the previous. But your previous got error. The prediction will be also erroneous. Because we cannot directly extrapolate. No, that extrapolation is means of learning adaptivity. That's why that is important like the learning. Previously we used to do it, but now we have data. Now we have got 6 months data, 1 person data, 1 old data, 2 year old data is both. Data speaks the truth. That's why there is a question called veracity. That is conforming to the fact. If you're see, you have one, you have unit them, and you have some models. Some models have controlled, some models have to get more. So it is your task to tune it, your task is to modify it. That is, you have to do the science. You have to develop new architecture. You have to develop new models. Just I buy from the model and I use it. That's why neural network died. Because everybody expected multi-layer password to be solved by all methods. You buy from the market, bankers are coming to us, insurance people are approach us, so why don't your student will apply? As if rest folks, they are applying to everyone to get money. They say that your multi-layer percent from your daily, you get like is not so easy. That's why I go as subject guide. We do not develop any new one. Similarly, I am attending now. The way everybody is coming, jumping, job market. College, I was told that if you have deep learning one, you get 80,000. If you have mechanical you get 40,000. Some private. In Hyderabad also, I was told. I was also told. There are no students want to go for mechanical engineering. All going for data science, cryptology, machine learning, all things. This is a very dangerous thing. Yes, now that is the character. You want to make it a simplified, how can it be? You look at the data, so you accordingly extract feature. You accordingly model. That's why you need to develop new technology. See, perception I explained as an example, simple model. Like I told when that you have number of classes 2 or the boundary is not linear, perception phase, you have multi-layer perception. Now in early 2000, we discovered certain breakthrough of multi-layer perception, and that led the advent of deep learning. Deep learning is learning in different stages in depth. Learning in different stages in depth, but you are learning the feature repetition rather than the task. That I will explain tomorrow. In machine learning, we learning the task. When you have the training sample, memory puzzle, only the task we are learning. But deep learning, we don't transform. We extract the more data representation from the data. So you are getting some data. You apply data, you get something. You take another data, you get another data. That is, you give more information to represent the data rather than the task. There is a learning in depth. But again, I tell you, when you look at the data, it's not a single that whatever you generate from college, that is you are down. That's why. Oh, that's it. More my trying to understand why are these why it doesn't mean they don't overlap. If there's overlapping, there's a complete screen. We are going to find that. If there is overlapping classes, because fuzziness is you are giving expensive now, you are competing membership. So you have defined whether you need fuzziness or not. Understand the thing? Fuzzy said between low media. Fuzzy said in beautiful way, then it will be just fuzziness, will be the fuzziness is the brain memory. So similarly, you think about whether fuzziness is the boundary. You think whether they you just think of it. Similarly, the granularity also. Everybody using fuzzy and also. No. No good. So, let's take online কিছু প্রশ্ন আছে if anything is relevant in the news, take one or two. What is data science and what is not? What is data science?
Tomorrow, what is data science? That is the third. So can we get the soft copy of the page? No, it's YouTube link is there. So in the YouTube, in about YouTube channel, you can see the presentation. And ma'am, so there's no more questions. So today is 2 o'clock. So tomorrow we will have same time, 12 o'clock. This. So I request all the participants to be present tomorrow at the same time. We will continue with this session.
The basic concept, I'm thinking point and telling that one of the actually you have study what is the time. We had something something. Okay, you can do it with this one. It is very different to publish the about all these
Okay, sir. Thank you so much. Thank you all from participating. So tomorrow, same time, 12 o'clock, all of you are going to be there for continuation of the